Welcome back. So, today we are back with one more interesting video. In today's video, we are going to explain about some example codes, like how are we going to write a code in data flow modeling, some simple ways to write a code in data flow modeling. Okay, so I already explained some of the codes in the previous video also. Okay, if you don't see that video, I'll link that in the description box. You can go check it out. Okay, and today I'll be explaining you some more codes in data flow modeling. Then we can go for behavioral modeling. Okay, so we are going in a flow, like first we have discussed about gate level modeling, and then data flow modeling, and then we will be going for behavioral modeling. Got it? Right. So before getting into video, if you like my video, just give me a small like, so that it will motivate me to bring you more videos. And also, if you are new to this channel, consider subscribing the channel and hit on the notification bell. Also follow me on LinkedIn, where I'll be uploading the slides of this particular videos. Okay, so let's dive into the video now. So as I told you, today we are going to explain some basic codes, how to write a code in data flow modeling. Clear? So this is the basic full adder. If you see here, this is the basic code for a full adder. This is my particular block diagram, and this is the truth table, and based on this truth table, these are the logics. So based on this logic, you will be writing the code. Okay, I think I no need to explain about the full adder. So basically every one of you know, like we have already discussed it in gate level modeling and all. So just by using, so since this is the full adder, if you see, it is having three inputs, a, b, c, and sum and c out are outputs, right? So in the same way, input a, b, c, and s and c out are outputs. And this is my logic. If you see here, what is the logic here? A XOR B XOR C in, and here A dot B plus B dot C plus A dot C in. So in data flow modeling, when this comes to dot, you will be using some operators. Okay, like bitwise operators, like and. For plus it is or. Okay, in this way. And for XOR, you are having some other operator in Verilog. So based on these operators, you will be writing the code. Okay, so if you see here, since you are writing a data flow modeling, what is the most important thing you need to remember? You should use the keyword assign. Okay, and also one more important thing that you should remember is this s. Okay, whatever it may be, either s or cout, any lhs. Okay, any lhs variable should always be wire. If you are mentioning it as rich here, then it will throw you an error. Okay, you should remember that. The simulator throws you error because the LHS of data flow modeling should always be of wire data type. Okay, that is why I have also explained that in data flow modeling starting video. You can check out that. Okay, so assign S. Now this is the XOR. Okay, this is XOR operator for data in data flow modeling. Okay, so A XOR B XOR C in, assign S equal to. Okay, assign C out equal to. Okay, you don't have dot and plus in like operators. So instead of dot, you will be using and, instead of plus, you will be using or symbol. Okay, this or symbol will be like this. Okay, clear? So this is how the code, basic RTL code will be. Okay, now what you have to do in order to check whether your full adder is working in correct way or not, you will be passing the values. From where you will be passing the values? Through test bench code. Okay, in test bench code module. Okay, TB top, just like full adder, I'm giving one more name like TB top. And since here they are inputs, so that is why we'll be mentioning them as rich, A, B, C. Okay, either you can mention it as C in or C. Either you can give it as same names, or you can mention it as different names. There is no problem in that. Okay, but mostly in any codes, if you see, mostly they will be using the same name, so that there won't be any confusion between the codes. That is the reason mostly they will use same variable names. Okay, and then s and c out. Now what I'm doing, I'm just instantiating my RTL code in this TB. Okay, full adder, any with name. You can write it as FA, or you can write it as DUT or UUT. You can mention any name you want. Okay, and N, it is in port connection by order A, B, C. Okay, S, C out. Okay, in the same way, just like you mentioned this, you should mention the ports in the same order so that they will be connected to this particular ports in the RTL code. Okay, and then initial begin. Now, since you want to monitor all the inputs, you will be writing dollar monitor. You will only be using dollar monitor in order to uh, show the, in order to see all your codes, basically all the inputs you are going to drive into this RTL code. You will be using only dollar monitor. Why don't you use dollar display? You can also see that in the previous session. Like I have already explained you why do we use dollar monitor and instead of dollar display. Okay, in test bench code I have already explained that. You as I told you, I'll be linking that in the description box. You can go there and check it out. Okay, now after writing dollar monitor, I also want to know the time at which that particular is taking place, because I'm giving delay here for every one clock cycle. This operation, this value should be driving into this particular RTL. So that is why I am just taking the time also. Along with time, I will be taking all the values A, B, C in, and some C out. Okay, all are like percentage B, percentage B. Okay, and now I am just driving the values. What are the values I'm trying? Like 0, 0, 0 one time, and then after hash one, like after one time, one clock cycle. Okay, that means for this clock cycle the values will be AB0. After one clock cycle, again the values will be changing it here. So in this way, there will be, the values will be driven for every alternative clock cycle. Got my point? So after driving some set of values, I'll be ending. Since I have written begin here, you should remember it. Like initial begin, since you are beginning it, you should end it and then end the module. If you are not if you are not writing either begin or end, or if you have written begin and if you have forgotten the end, then it will throw you an error showing you the begin and mismatch. Okay, so this is how you will be writing your RTL code and test bench code in data flow modeling for full adder. Now, since I have explained you how to write a full adder, try it. Since I have given you like block diagram and along with some truth table and the logic also, try to write the half adder code. Okay, and if you are writing the half adder code, try to take the snapshot and give me, and play. Show me it in either LinkedIn, or else just comment me whether you have written it or not, so that it may help me, like you're following me, and I'll be creating much more videos like this. Okay, so this is like, because try to write any program, like either you show it to me or not, it's your wish, but try to write as many codes as you prefer, because basically when it comes to writing the code, the practice is the key here. Okay, how many codes you could, because basically whenever you're writing code on paper, and also while writing the code on paper, try to execute it on the EDA playground, because writing it hardly on paper is different from executing it in the EDA playground. So try it, if you are writing like some 5 to 6 codes, try to at least execute 2 to 3 codes of that in EDA playground, so that you will understand where are the, because basically some syntax errors, they may seem very small. Like while I used to start writing codes in Verilog, while I'm writing on paper, I used to write it roughly. So when I'm just copying what I'm writing in the paper and executing in the EDA playground, there used to be lot of errors. So these errors are not very high end errors like that. Okay, just a small space between end and module. Actually between end module you shouldn't have any space, but if you keep any space between end and module, that is also an error. Is it or not? Because these are syntax errors, they need to be corrected by you only when you practice and simulate the code on EDA playground. So that is why my suggestion for you is, when you are writing, trying to write the code, try, if you are writing code like some 5 or 6 codes on the paper, try to execute at least 2 or 3 on the any, like any playground, not only EDA playground, and any different simulators you can do it. Okay, so this is the thing for you. And then now I'm going to explain one more code. So for this code, what we will do is we will try to execute it on the EDA playground. So before executing that, first let us write it on the um, write it here first. Okay, so this is the binary encoder. So you already know that encoder is nothing but it is having 2 power n inputs and n outputs, is it or not? So here basically what I am taking is 8 by 3 encoder. Okay, that means 8 inputs and 3 outputs. So if you see here, these are my inputs from D0 to D7, and these are my outputs Y2, Y1, Y0. So if you see here, when the encoder, these are the particular, like if you see, if D0 is 1, then the values are all zeros. Okay, Y2, Y1, Y0 is all zeros. If D1 is 1, if you see here, D1 is 1, then the output Y0 is activated in the similar way like this. Okay, I think you can understand the truth table here. So based on this truth table and based on the output, we are writing the logical expression. Okay, so if you see the logical expression, what is the Y2 logical expression? Here all are 0. So where is it? D4, D5, D6, D7. So that is what. For Y1, if you see, D3, D2, D3, okay, D6, D7. So this is what. And then coming to Y0, if you see, what is the Y0? It is D1, D3, D5, D7. Okay, so this is my logical expression. So now by taking this logical expression into consideration, I will be writing my code. Okay, now let us start writing my code. If you are seeing this video, just try to write parallelly with me so that you will also get confident on writing a code in data flow modeling. Okay, so first, what is it? Module, like any name you can give. Since this is encoder, I am giving encoder 3 by 8 encoder, so that is why. Okay, now I am having like taking inputs D1, D2, D3. Okay, don't give it like this, just for as for now I'm just writing it. You should write it like D5, D6. Okay, I'll also be writing it along with you. And these are the inputs. Okay, from D1 to, I think it is, yeah, D0 to, sorry, from D0 to D7, and then coming to outputs Y0, Y1, Y2. Okay, so these are my inputs, outputs. Okay, now coming to what are the inputs? Inputs are from D0 to D7. Outputs are Y0, Y1, Y2. Okay, now coming to, this is my inputs and outputs declaration. That is all we need. Now coming to the logic. So for logic, what we have to do? First write assign. Okay, I am starting with Y0. What is Y0? Assign Y0 equal to D1 XOR D3 XOR D5 XOR D7. Sorry, or not XOR. D1 or D3 or D5 or D7. Since it is plus, so it is OR. Similarly for the remaining two also. Like assign Y1 D2 or D3 or D6 or D7. Similarly for Y2 also. D4 or D5 or D6 or D7. And then end module. That's it. This is your basic code. That is all you need to do. Okay. And then coming to test bench, what are you going to write? This all you, I think you know about this already, like module, okay, TB, and you will be writing all inputs and out. Okay, sorry, you don't be writing this module TB. And then what you will be doing, since input you will be mentioning it as reg, output as wire, and you will be mentioning all the values here like Y0, Y1, Y2. Okay, in this way. And then now after doing all such things, then what you will do within initial begin, first you will be writing dollar monitor. Okay, and then you will be displaying everything here, and then after this what you will do, you will be throwing the values. So since you are having like from d0 to d7, you are having all these values. Basically when you are beginner and when you are writing it in just a rough way, you can do it like this. Like you can throw as d0 equal to 0, d1 equal to 0, d2 equal to 1, d3 equal to 0, d4 equal to 1, d5 in your similar way, like whatever way you like you can do it. Okay, d6 equal to 1, d7 equal to 0, and then in this way you can just be writing all the values. Like then after hash 5 seconds you can again change the input values. You can do it, and then after this you will be writing end and end module. Okay, that is it, you will be writing. So basically you can either write it in this way, or if you're a beginner, basically you will be writing it normally in this way. But when you go on practicing and you when want to have, because every code will be having its simplest form, no one can say that this is the last way to write a code. Okay, you are having many other ways to write a code, so that is why this is one way. Like for this same code I'll be showing one more way to write a code. If you see here, so here instead of taking, see what I have done, instead of taking so many variables from d0 to d7, I have just taken one variable named d and then increasing its width. Okay, if you see here what I am doing, I increasing the width of the variable d. Now what will happen, this d can hold 8 bits. Okay, that is what I'm doing here, is it or not? But instead of storing each bit in a single number, single line, I'm just storing all the bits in only one way. Okay, so you can do it in this way. So if you see here, this is my d, and then I'm giving it as in the same way. Instead of taking three variables y0, y1, y2, I'm also increasing the y2 length like 2 down to 0. Now based on this you will be writing just like writing d4 d5, you will be writing d of 4 d of 5 and everything. Okay, now if you are taking in this way, you can reduce your test bench code. Like how, if you see here, this is my region wire obviously, and I'm taking another variable like int I. Okay, this is another variable I am taking I. Why? So here if you see, this is my instantiation, and then within initial begin. Okay, so here what I'm doing is I'm not writing dollar monitor. Okay, why I'm not writing dollar monitor but I'm writing dollar display here? Why? Because basically if you see here, first I am taking d as 8 tick b1. So this is my d value. What is the value that I'm taking for my thing? This is 8 tick, so it is of 8 width, 0 0 0 0 0 0 0 1. Okay, this is the width of my d. This is the value that I'm taking for my d. Now after one time period, like hash 1, after one clock unit of time, I'm writing my for loop. I think you already know about for loop if you are familiar with any other language also. Like in for loop, what it will be happening, first initialization and then condition, and then you will be adding something like you will be doing I plus plus and all. Now I am taking the value like I equal to 0 and then I less than 8. Okay, why it is I less than 8? Because it is of 8 bit, so I'm just taking 8 I is less than 8 and I plus plus. Okay, this is my for loop, and then within for loop, after for loop I am writing begin, and then I am writing dollar display. So in this dollar display I want to display d as well as y. Okay, so along with I also, d I y, these are the things I want to display. So after displaying, what I'm doing, since this is a for loop, until this condition is false, the for loop will be looping, like it will be rotating it from here to here, is it or not? So that is why I'm writing display, because here what will happen, the display function will be every time it will be displayed after this for loop is executed, it will come to display, and then again since the condition is false, it will again go to this line and again go to for loop. Okay, so now after display, what is the condition I am giving? D equal to d shift 1. If you see here, this is my shifting processor. Okay, what is this? This is the logical shift operation. Okay, which shift is it? Is it a right shift or left shift? I already told in while we are discussing about operators, how to know, like how to don't get confused between left shift and right shift. So this is left shift. Why? Because L is in this way and you can just imagine it as an L. So this is left shift, which is a logical shift. Now D, I'm shifting it left shift for, if you see here, for one time. That means we are shifting the value for one time. Now if you come here, this is my shift. Now this is will be shifting it like this. So what happens, this one comes here and this is filled with again zeros. Now what will be the value of t? Here this is 1. Now it is basically 2. Did you get my point here? So now D is 2. Again it goes here. I equal to 0, I less than 8. Now here I is printed as 1. Actually why? Because here I didn't give I value. Okay, I am just giving the value of I is, here it is initialized to 0. So here I plus plus means value of it is 1. So 1 means it is less than 8. Again it will be going here and again displayed in this way. The for loop will be continued. Clear? Did you get my point? So this is how basically the thing will be happening here. In this way also you can write a code. Instead of writing the code like this, instead of writing all the values before I have explained, like instead of writing dumping all the values like 0 1, in this way, instead of writing all those values, you can just write it by taking a single variable. So if you see here, by using, instead of writing, for example, if I want to throw values for 8 times, in this way I need to write some 8 lines of code. Is it or not? Now this 8 lines of code is reduced to 3 lines of code by writing a for loop. Okay, that is what it is needed. That is basically, when you see in any data flow modeling, operators are something which are important, because when will they be important is when you learn to implement them in your code. So any in any language, like all the basics they will be explaining, these are mostly important when when and only you will implement them on the code. Okay, so try to implement the code with the things that you learn. Okay, then only that language is useful for you, and also you will get grip on that language. Okay, when you are always writing a code in a same way, then there is no growth for you. Okay, when you think out of your box, only you will learn how to grow in your career or in your life. Okay, so try to write the code in different way, in different models, like by using different operators. Now I have used for loop here. You can also write it by using a while loop, or you can also write it using any other thing. Okay, so in this way you will be writing your codes. So that is all for binary encoder. And here what I am doing is, since I have explained you about binary encoder, try to write the binary decoder code. Okay, so today I'm asking you to write like two. So every day, just think of one day every day before, if you are a college student or if you are a beginner also, try to write at least 1 to 2 codes and try to execute one code on the EDA playground, so that everything will start with the small step, but these small steps only will make you grow more in your life. So that is why try to write at least 2 codes for a day. Okay, so today I am asking you to write like binary decoder and half adder. Okay, so try to write these codes and try to implement any of these codes on the EDA playground. Okay, or any platform that you are familiar with, right? So that is all for today. So if you like my explanation, and if you want me to bring you more such videos, please consider subscribing my channel and hit on the notification bell also, so that you will be getting updates as soon as I upload the video. And also do like me and follow me on the LinkedIn, where I'll be uploading the video.